Hello everyone, and welcome to another part of the Galaga SDL tutorial videos. In this video we're going to be doing the pathing for the enemies. So we're not going to be creating the actual enemies in this video, just the paths that they're going to follow, because all our enemies are going to more or less follow the same paths when they're coming into the level. And then we're going to create classes for them later on to add more behaviors for their diving paths. But for the fly into the level, we just need to have them all follow the same paths. So the first thing that we're going to do is to describe what a Bezier curve is. And for that we will go to our mathhelper.h, and all the way at the end we are going to create a new struct. So what is a Bezier curve? I have here a Bezier curve editor, and a Bezier curve is made out of a start point and a control point for it, and then an end point and a control point for that end point. So what we're going to do is to create our struct. So it's struct Bezier curve, and this one will have 4 points, all of them vector 2. So vector 2 p0, which is our start point, vector 2 p1, which is our control for our start point, and then vector 2 p2, which is the control for our endpoint, and finally vector 2 p3, which is our endpoint. And that would be it for the 4 points describing a curve. Now the only thing that we need to do inside this struct as well is to create a function to give us a point on that curve. So for this we will go down here and make a function that returns a vector 2. So vector 2 calculate curve point, and this one will take a float t, and that's a vector 2. So what this will do is to give us back a point on this curve in relation to t. So when t is 0 we get our start point, when t is 1 we get our end point, and when t is somewhere in between we get an interpolation between these 2 points, depending on how the control points describe that curve. So we will need t squared, so we'll start off by doing that. So float tt is going to be equal to t times t. We will also need t cubed, so float t is going to be equal to tt times t. And then we will also need 1 minus t, and we'll call this one u. So float u is going to be equal to 1.0f minus t. And then we'll need u squared and u cubed, so float u is going to be equal to u times u, and float u is going to be equal to uu times u. And these will be all the variables that we're going to need, all the floats that we're going to need for our equation. Now we can create our vector that we're going to return. So vector 2 redval is going, or actually we can call it point, is going to be equal to, so for our point we need to pass it u cubed multiplied by p0, and this will already give us an error because we don't have a way to multiply a scalar on the left side by a vector. And to fix this we need to go up to where we're overloading the operator of times equals. We can copy it and paste it, and then now on the left side we can make that one a float, and on the right side a vector 2. Now in here we will need to change this to left hand side multiplied by right hand side dot x, and left hand side multiplied by right hand side dot y. And that will be it for that. If we go down here, it should now know how to multiply a vector by scalar when the scalar is on the left side. So this plus 3 times u squared multiplied by t multiplied by p1 plus 3 times u multiplied by t squared, so tt multiplied by p2, and then finally plus, that will be t cubed, so ttt multiplied by p3. And that will be it for our Bezier curve point. Finally, now since SDL only uses integers for pixel points, or for positions, we need to round this to the closest int. And to do this, we are going to say point. So point.x equals round to the nearest x, which will be round point.x, and point.y is going to be equal to round point.y. And then finally just return point. And that will be it for our Bezier curve. Next up, what we need to do is to create a path. And we'll create a path by stitching multiple curves together. So over here, we can go to our header files and add a new item. And this one will be calling Bezier path. So in our .h, we'll do our usual if not defined. So if not defined underscore Bezier path underscore h, define underscore Bezier path underscore h, and then endf class Bezier path. Okay, so what we'll need in here is our mathhelper.h. So include mathhelper.h, and we'll also need vector. So include vector. And our path, our Bezier path, will be made out of curves, so multiple curves. So we will need in private, we'll have std vector Bezier curve. So we will need multiple curves, right? We need to be using namespace SD, namespace quick SDL. There we go. So now it knows what Bezier curve is, and then call this one M curves. So now we have an std vector of how many curves, of all the curves that we have, and we will need another std vector. This one will be an integer one, and call this one M samples. And this will be used to sample this curve so that it's not just a continuous curve, it will be made out of small lines. And we can tell it how many samples we want for each curve. And these are all the variables that we're going to need in this class. Next up are the functions. So public Bezier path, and then destructor Bezier path. Oh, this one needs to be a destructor. And then void add curve. So this one will be adding a curve to our array. So we'll have a Bezier curve, and int samples. So that will be this function, and then void sample. And this one will take in a pointer to a vector of vector 2's. So std vector, vector2, pointer, sampled path. So what this will do is take in a vector and then populate it by the sampled path described using our curves. And that will be it for our .h file. Next up, we can create our .cpp. So over here in our source file, add new item, and we'll call this one Bezier path, and we'll include our Bezier path.h. There we go. For the constructor and the destructor, they're going to be empty for now, but I like to declare them anyway. So Bezier path, that's empty, and then Bezier path destructor, Bezier path, so that's empty as well. Now for add curve, all that's going to do is push a new curve onto here and the samples onto there. So void Bezier path add curve. This will take in a Bezier curve, and an integer samples. And all this would do is say that M curves dot push back the curve that we have, and M samples dot push back our samples. And this will be it for add curves. And finally, sample is the last one that we need. So void sample, this one takes in an std vector of vector 2's, and this will be a pointer, and then this one is called sampled path. So what this will do is loop through our curves and sample them by the amount of samples that we need in our samples vector. So the first thing that we're going to do is for int I equals 0. I is less than mcurves.count. Oh, probably need to add this here. So Bezier path, colon. So curves.size, and then I++. There we go. So now we're looping through all our curves, and we need to sample these curves by the amount of samples that we have in here. So for int, or float actually, for float t equals 0, t is less than or equal to 1.0f, because t in our calculate curve point, t is always somewhere between 0 and 1. So we need to go from 0 to 1, but the increments that we have are going to depend on our samples. So we can say t plus equals 1.0f divided by m samples at I. So what this will do is increment t by, let's say our samples are 2, it's going to increase it by 1 over 2 each time up to 1. So it's going to be 0.5 and then 1. If we have samples at 50, it's going to be a 50th each time up to 1. And then finally we can say the sample path pushback m curves at I dot calculate curve point at t. And that will be it for this class. Now we are ready to actually make one of these paths, but the first thing that we need to do before that is to be able to draw a line. And for that we're going to be going to our graphics.h. So in graphics.h we'll go down to where our draw texture is and add another method right underneath it called draw line. And what this will take is a float start x, a float start y, a float end x, and a float end y. And this will just help us visualize what our curve looks like. So in draw line, we need to implement it in graphics.cpp, so we can go there now and go all the way down underneath draw texture, and over here we'll say void graphics draw line float start x, float start y, float end x, float end y. And the first thing that we're going to need to do is to set our rendering to white. So that will be SDL underscore set render. So set render draw color. And this will take in our renderer, so mrenderer. And the color will be 255, 255, 255. And the alpha will be SDL underscore alpha. Alpha opaque. There we go. And then next up we need to draw these lines. So SDL underscore render draw line. And this will take our mrenderer and then our starting positions and end positions. So start x, start y, end x, and y. And then we need to set our render color back to black, because over here we have it in the init, we have it always black so that we can get the black texture for free, the black background for free. So over here we'll set the render color to 0, 0, and 0. And then the alpha is still opaque. So that will be it for our draw line function. Now we can go ahead and create one of these paths. And for that we will go to our level.h. So in level.h we have over here our pretty much everything that we need. Actually, maybe we can create our enemy, the base enemy class right now. Let's do that then. So in Galaga, in the filter, add new item, and at the .h we'll add enemy.h. So over here we'll do if not defined underscore enemy underscore h, define underscore enemy underscore h, and then end f. In enemy, we will include animated texture.h because all the enemies pretty much animate. And then we'll also include Bezier path.h. So now that we have these two, we can create our class. So using namespace, actually, that's already being used in Bezier path, so we don't even need to do it here. Class enemy, public game entity. Okay, so now that we have our enemy, we can go ahead and get started on the paths, because all the paths are going to be pretty much shared between all the enemies. So we can make them static. So we'll do static. So this is private, of course. Static std vector, and this will be a 2D vector. So std vector of vector 2's, and these will describe all our paths. So we'll call this one as paths. Next up, we will also have our states. So we have a few states for the enemy. So enum states, and states will contain fly in. So this is when the enemy is coming onto the screen, and then formation. That's when they're in formation, and then dive, and dead. And these are going to be the 4 states for now. We'll probably add more states later for the challenging stages and so on, but these are fine for now. Next up is the timer pointer. So timer pointer, mtimer, and then a texture pointer for now. We'll call this one mtexture. We'll use this one to test what the path looks like on the enemy. So that should be fine for now. And then states current state. So this is the current state that we're going to be in. It's going to start off being fly in, and then we're going to change the state depending on where we are right now or at the time. So if the enemy starts diving, the state's going to be dive, and so on. Okay, and then we'll have an int current path. Because we have multiple paths, we need to tell the enemy which path they're going to be taken when they're flying in. And then int current waypoint. So this is the waypoint that the enemy will be interpolating through because our paths are sampled. And then const float epsilon. And this one will be equal to 5.0f. So if epsilon, so this is how far we want to be from a waypoint to move on to the next one, so that we don't, because most likely we're not going to end up right on top of the waypoint to increment it. So we need to get close enough to increment the waypoint and then just move on to the next one to start interpolating to the next waypoint. So that should be it for that. And then that will be it for our variables that we need. Next up are the functions. So public, we will need to create an enemy. So enemy, and the enemy will take in an int path, and then the destructor enemy. That should be fine. Now, next up, we will need a function for each state that we're in. Right, the destructor probably needs to be virtual. So we have our virtual destructor, and then virtual void handle fly in state, virtual void handle formation state, virtual void handle dive state, and virtual void handle dead state. So next up, we will have void handle states and void update, and void render. Okay, and as you might have guessed, depending on our state, we're going to call one of these functions in the handle states function. So now that we have everything set up in the .h, we can go ahead to the .cpp and start implementing some of these functions. Okay, so in Galaga, add new item, enemy.cpp, and then we'll include enemy.h in here. Okay, so the first thing that we need to do is to initialize our path. So, or give the CPP file access to the path. So we'll do std vector, vector2, enemy as path. There we go. So that's for our static, but we need also a way to build these paths. So we'll go back to our functions, and all the way at the top we will have a static void create paths. And this will be called only once. So we'll probably be calling it from the play screen just to create all our paths for us. So let's start off by implementing this create paths function. So let's say void enemy create paths, enemy create paths. Okay, so the first thing that we're going to do is to create a Bezier curve pointer, and we'll call this one path for now. And this one is going to be equal to a new Bezier path. And then all the way at the end we'll delete the path. Now in between, we need to add curves to this path and then sample it. So we will do sPath dot pushback and std vector of vector2s. There we go. So we're adding a new vector2 in here, and then we will probably need an integer for the current path that we're on. So int current path is going to be equal to 0. So we're starting off at 0, and then we'll say that path sample, and we'll pass it in the current path. So sPath at current path. And this will be a reference to this vector. So reference. Okay, so now that we have everything set up, we're creating our path. We are pushing a new vector2 in our static paths for all the enemies. And then we're sampling this Bezier path and passing it our this one path that we need. So let's add a few points to this path. So we will do path at curve. Okay, and a curve is, as we have done earlier, is made out of 4 points. So this one is the start and control, and then control for the end, and then end. And I have here this thing. So this is a Bezier curve editor. As you can see here, to make a straight line, there we go. To make a straight line, the slope between these 2 points and these 2 points needs to be the same as the slope between these 2 points. So let's start off by creating just a straight line, a straight vertical line. So we'll go to enemy.cpp and add, so to add this, so we'll do a vector2, 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 and vector2. So this will describe our curves, and the samples will set to 1 for now. So we now need to describe the points for these vectors. So let's start off by something like, let's say, so this is our starting point. So let's say something like 500 on the x, 500.0f on the x, and let's say it's around 10.0f on the y. So we have this one here, and then the control point needs to be a little bit above it. So let's say something like 500.0f on the x and 0.0f on the y. Now for this one, it needs to be way underneath it, but still the same on the x. So this one will be 500.0f on the x, and let's say something like, so there's a 10 difference. So let's say 310.0f on the y, because this point is the control point for the end. And then the end point needs to be above it by 10. So 500.0f on the x and 300.0f on the y. And now we have our first curve. So we're creating the path, we're adding the curve, and then we're sampling it. So now we have on paths at 0, we should have a sampled path there. So this should be it for now. We'll add more paths in a little bit, but we can go ahead and implement the rest of our functions. So our constructor, void or enemy, this one will take an int path, so int path. We first need to get our timer instance, so mTimer is going to be equal to a timer instance. And then mCurrentPath is going to be equal to path, so that's fine as well. And then our position is going to be the starting point of this path. So what we can do is say our position is going to be equal to sPath at the current path, so mCurrentPath, at 0. So this is going to be our starting position. Our current waypoint is going to be equal to 0. Actually, what we can do is set the current point to 0 and set the path to be at the current path and the current waypoint. So that's going to be at, if we pass in path 0, so it's going to be at 0, 0. And that will be it for this. Our current state, so mCurrent state is going to be equal to fly in. And the last thing that we need to do is to just load up a texture to describe our enemy. And for that, I already have a texture of one of the enemies, which is the butterfly. So in assets, there we go. There we go. So I cut up one of the enemies, so that's the butterfly. We'll use it to describe just a simple enemy for now, and then we will make a class for each enemy to describe their behaviors and give them their own textures. But for now, we'll use this one. So what we can say now is mTexture is going to be equal to a new texture, and this one will be, I think it's called butterfly.png, so butterfly.png, and then mTexture parent is going to be this, and mTexture position is going to be vector2 0 to center it on our object. And that will be it for our constructor. Next up is our destructor. So enemy, and in here we will just set the timer back to null. So mTimer is equal to null, and delete mTexture, and mTexture is going to be equal to null. And that will be it for our enemy destructor. Next up is our fly-in state. So void enemy. Actually, let's do handle states first. Handle states. Okay, so handle state, what it's going to do is switch the current state and call the corresponding function to that state. So we can do switch mCurrent state, and then case fly in break. This one will be handle flying state, case formation break, handle formation state, case dive break, handle dive state, and then case dead break, handle dead state. And that will be it for our handle states. Now for our update and render, we can do void enemy update if active. So as long as the enemy is active, handle its states. So we can say handle states, and then void enemy render if active. We want to render the texture, so on texture render, and then we want to also, for now, output the path. For this, we are going to loop through our sampled path and draw all the lines corresponding to it. So for int I equals 0, I is less than s paths at the current path, dot size minus 1, because we're going from a point, because the path is made out of points and each line will be at our point to our point plus 1. So we don't want to go out of range, so we'll go up to minus 1 and then I plus plus. There we go. Next up is our rendering. So we can say graphics, instance, draw a line, and our line will be our current path, so s paths at the current path, and I.x, and then the same idea, so we can copy this, dot y, and then paste it again, dot x, but this one is I plus 1, dot x, and then again, but this one would be dot y, and I plus 1. And yeah, that should be it. So we're rendering the current path dot x and dot y, and then I plus 1 dot x and I plus 1 dot y. And this will be it to render our path. Now we need to implement our state functions. So these three states we're going to leave empty for now because we're only concerned about the flying state. So we can say void enemy handle formation state. We can leave it empty. Void enemy handle dive state and leave it empty, and void enemy handle dead state and leave it empty. Now all the way at the top, we can now implement our flying state. So void enemy handle flying state. And what the flying state will do is to interpolate along this path until it reaches the last point. And once it reaches the last point, we can say that it's in the formation state. For now, we're not going to tell it where the formation state is. For now, as long as we get to the end of the path, we'll just set it to the formation state. So if s paths at the current path and the current waypoint minus our world position, so minus our position, so we'll probably need to put these two between brackets. So if we get the vector, which is the distance between these two, dot magnitude, actually we can use magnitude square. That's a bit more efficient. So if the distance between these 2 points, which is our current position and the waypoint we're trying to get to, the square of the magnitude is less than the epsilon value that we declared, so it's less than epsilon, we can increment to the next waypoint. So we probably don't need the brackets. So m current waypoint plus plus. And then if the current waypoint is less than the s paths at the current path dot size. So as long as we're still in range of the path, keep interpolating to the next waypoint. Else, we finish the path and we need to set our state to the formation state. So m current state is going to be equal to formation. So now in here we need to do the interpolation logic. So we'll say vector2 distance is going to be equal to so the distance is going to be equal to the s paths at the current path and the current waypoint minus our world position. So this is the distance from the waypoint from where we are, and then we want to interpolate towards that. And to do this, we just need to get the normalized distance. So we can do translate. So we need to translate along the distance dot normalized multiplied by the timer, delta time, multiplied by our speed. And we probably need to declare that. We haven't declared it yet. So over here, float m speed. So in the enemy.h, we can add our m speed. And then in enemy constructor, over here, we can say m speed is going to be equal to 100.0f. And then we can go back down to our handle state and multiply by m speed. So this will be it for our translate. And that will be it for actually pretty much everything that we need for now. Okay, now we can create an enemy and test it out and see if it works. But first, let's try to compile and see if we caused any errors. Wow, no errors, okay. That sounds good to me. Okay, so now we can go to our play screen. So play screen.h, and we want to create all, or play screen.h actually. In level.h, we need to include enemy first. So include enemy so that we have access to the enemy in the play screen. So in level.h, we're including enemy.h. And then in play screen.cpp, what we can do is go to our constructor and over here say enemy create paths, because the play screen is only created once, so we want to create all the paths before any levels are created, and no levels are created in the constructor, so we can just create all the paths there. So this should be it for the, so it's in the play screen constructor. We added that. And then in the level, we can go ahead and create one of the enemies and see what they look like. So enemy pointer, enemy. And then in level.cpp, all the way at the end here, we can say enemy equals a new enemy. And the path will be 0 because we only have a single path for now. So we will go with path number 0. And then over here, we will delete enemy and set enemy to null. There we go. And then we will do an enemy update and an enemy render. So in the update, whenever we're right before the collisions, we can say enemy update. And right here, right before the player hit, we can say enemy render. And this will be it for that. Let's try to run it and see what that looks like. So hopefully that renders our path for the enemy, our sampled path. There we go. So we have our path now, and we're interpolating between it. Once it gets here, it's in formation state, and it stops. So let's try to create one of the original paths for the game. And for that, I have a few values that I already figured out. But this will be a lot of trial and error. Okay, so in enemy.cpp, over here, we can start creating all our paths. So for the first one, we will have the path which goes like this. So paint one of the paths in the original Galaga. It came out from the top, and then they came in here, and then did a rotation and then went to wherever the formation is. So our path will look like this. So they will go down and do the rotation and then stop right here because we're not giving them a formation position yet. But once we do that, they're going to be translate from there to whatever they should be in the formation. So this will be what our path looks like. So the values for this will be, we'll probably need the halfway point in our level. So the halfway point is where our start label was. So in play screen, in start it was at graphics times 0.4. The width times 0.4 was our midpoint. So we'll go back here and we'll make a new int. So int screen midpoint is going to be equal to graphics instance, and this is in our create paths in the enemies in the enemy.cpp. So instance screen width multiplied 0.4f. So we want to start from the midpoint. So let's say our midpoint was here. They started off a little bit past the midpoint because there was another path that looked like this. So we're doing this one. So we'll start at the midpoint plus 50 and we'll go to here. So this will be our first instance of the curve. So we will do midpoint. So our first vector is going to be midpoint plus 50.0f, and its control point will be the same thing, midpoint plus 50.0f. Now we want the enemy to start off screen. So to make it start off screen, we will make our start point -10 and our control point -20 on the y. So midpoint plus 50 minus 10 and midpoint plus 50 minus 20. So this is our start point and control for our start point. Now our end point will be the same as the start point's x, so we can copy this and paste it here. So midpoint 50 and midpoint 50 as well for the y. Now we need to make it straight here, so this one will be a little bit underneath it. So for this one, for our endpoint will be at 20.0f. Oh. And for the control will be a little bit underneath it, so 30.0f. And that will be it for our first segment. So let's run it and see what that looks like. And like I said, this will be a lot of trial and error, so you can just change the curves a little bit to get the result that you want. And then if it's too jagged, you can increase the sampling size. But for straight lines, it's better to just keep the sampling size to be at 1. There we go. So it's coming down from here and stopping right there. So now we want it to curve down here. And to do this, we need to add another curve. So let's add another curve here. And the end point for the start point for our new curve will be the end point for our old curve. So we will take our endpoint. So this is our endpoint for the old curve right here. And this will be our starting point for the new curve. And the control position for it will be the same as the control position for the old one. So let's put that one here. And then let's see, we want it to be somewhere around here. For now, we'll make it a straight line and then add the curvature as we need. So over here, so we had midpoint plus 50 and midpoint plus 50, 20 and 30 for the position and the control point. And then we want this to be further down. So for this, we will make it around, I think I got something like 75 on the x. So on the x, 75.0, 75.0f, and 75.0f over here as well, 75.0f. So our x position will be 75 and our y position will be 325 and let's say 325. So they're both the exact same point for the control and the position, and we'll make a sampling of one. Let's see what that looks like and then edit it accordingly. There we go. So as you can see, it interpolates down there, and then it interpolates down here. And this seems to be working pretty well, but we want this to be curved a little bit. And to do a curve like that, if we go back to our editor, if we put this one to the right, to the left side, and this one to the right side, we end up with a curve that looks like this. And this is pretty much the kind of curve that we want. So we want the control point for the start to be to the right, to the left of our point, and the control point for the end to be to the right of our point. And that's what we're going to do. So our control point over here, instead of plus 50, we want it to be to the left. Actually, we want the control point to look something like this. And then like that. Because we want it to go straight and then start curving to the left. So we can have this one at the midpoint, plus 50, and for the y, it would be around 100. And let's see what this looks like. So let's increase the sampling size to like 25 and see what that looks like. There we go. As you can see, it's smoothed out and it turns to the left. And this is pretty much what we're going to be doing for all our paths. It's going to be a lot of trial and error, but it gives us the smoothest path that we can have. And it gives us a lot of control over how the enemy behaves when it's flying in. And it also has a constant speed along the path. So even though it might seem a bit convoluted with the waypoints and all that stuff, we can use this editor over here. So we can find any editor online to see what kind of control points that we need roughly, and then edit these control points to give us the specific path that we want. So now that we have this, we have over here, so we are at 75 and 325, and then 75 and 325. For this, I found that having this as 425 works out pretty well. So let's see what that looks like. There we go. So now we have our curve right here. So we just need to add another curve to rotate around this in a circular orbit. So to do this, we will add another curve. So what I did was change the 325 for the endpoint to 425 to make it lower. And then so what it looks like now is something like, so this one is over here, and then this one is over here. So that's what it actually looks like. There we go. So that's what it actually looks like. So now what we need to do is to have a circular path. And to do this, we need something like this for it. So they both should be on the same x-axis, the same x point, but the control points should be lower down on the y to give us that circular orbit. So what I found for that is, let's copy and paste this. We're starting from the same point here, so 75, so our start point 75.0f, and our y would be 425.0f. As you can see, our endpoint, so P3, the last one that we add, is always the same as P0 for the next curve, because it's all stitched together. So now that we have this, so 75 and 425 for the x. For this one, for the control point, will be 75.0 f on the x, and we want it to be lower down on the y. For that, I found that 650 was pretty good, so 650.0 f. And then we need it to be further on the x, so it was something like 325.0 f on the x, and then on the y would be 650 because this is the control point, and then 325.0 f on the x, and on the y it was 425.0 f because they are both lining up on the y. So 425 and 425, and the control points are lining up on the x, so 650 and 650. So let's see what this curve looks like. And there we go. So pretty much a curved path that it's going to be going through. If this is not the exact path that we want, we can pretty much, let's say, increase the distance between the x values. So if we don't want it to be at 325, we can make it at around 350 and 350. So this will make it further to the right. And let's see what that looks like. There we go. And that will be curving like that. So this seems to be working pretty well. The enemy is pretty slow. So let's increase the enemy speed a little bit. So enemy.cpp, enemy speed, let's make it something like 400. And we want the enemy to always point towards whichever direction it's going. So down here, we need to also make the enemy look in the direction wherever it's going. And to do this, we need to use the atan2 function. So we'll do the rotation is going to be equal to atan, and this will be, we'll take in this dot y and this dot x multiplied by, and we need, this is going to be returning a radian for us, and we actually need it to be a degree instead. So in math helper .h, we can go down here and define a radian to degree. So we will copy and paste that. Actually, we don't really need to, but whatever. Radian underscore to underscore degree. And this will be 180.0f divided by pi. So it's just the inverse of degree to radian. And then we will go back to our enemy.cpp multiplied by radian to degree. And finally, there's one more change that we need to do. The translation should be in world space. So this one will be world. And that should be it for this atan2. So atan2 of this, and let's see what that looks like. So let's run it. There we go. As you can see, it's the x-axis is the one that's pointing at it. So all we need to do is to just change the rotation by 90. So add 90 to that rotation to make the enemy look where it's going. So plus 90.0f. And that should make the enemy look in the direction that it is going. There we go. And now we have our enemies going in our, or moving along our path. If the path seems a bit too jagged, you can increase the resolution and it'll just follow that new resolution by itself. And I don't really want to make all the paths in this video because it's nearing on to an hour long already. But this should be a pretty rough idea of how the paths are going to be working for us. Maybe I will upload a quick video afterwards going through all the paths that we're going to be using for the enemy, but this is going to be one of them. Another one will be pretty much the mirrored version of this path as well, and then a few other ones. But for the purposes of this video, this should be it for the paths because the video is getting pretty long already. If you have any questions, suggestions, or feedback, please leave them below. Otherwise, thank you very much for watching, and I will see you in the next video.